So number one, here are the givens. Look at the upper part. I need to know which quadrant to go to. Is it 1, 2, 3, or 4? Well, they tell us that sine is that number. Sine is positive. So because sine is positive, it's either in 1 or in 2. Then they tell you that secant is positive. That narrows it down to quadrant 1. Because secant, if secant is positive, then cosine is also positive because they're just reciprocals. Now, if cosine's positive, we're in quadrant 1. So go to quadrant 1, make a right triangle. And that triangle has theta because it says theta. Now, sine is opposite over hypotenuse. So we have opposite 3, hypotenuse 5. Pythagorean would say 4. Done with the picture for theta. Now I need a picture for psi. Now notice that psi is between 540 and 630. Why don't we subtract 360 from this and from that to see that psi is an angle between 180 and 270. So I know that psi is going to terminate somewhere in quadrant 3. Yes, somewhere in quadrant 3. So I know that psi takes us somewhere there. And then tangent 3 is 3 over 1, right? You can put a 1 in the bottom. Tangent is opposite over adjacent. They would both be negative because you move left and down. Pythagorean gives you square root 10 for the hypotenuse. Now we can begin part A. Part A says sine of 2 theta. Looking at your trig identities, we know that sine 2 theta is the same as 2 times sine times cosine. 2 stays 2. Sine theta would be, well, that's given. They tell us that sine of theta is 3/5 times cosine of theta. Cosine is adjacent over hypotenuse. It says theta, so go to the triangle that has theta. And from here, cosine would be adjacent over hypotenuse. Calculator would say 24 over 25. Final answer for part A. Part B, let's have a gander at part B. Part B says tangent of half of psi. So go to your half angles. Tangent of psi over 2 would equal 1 minus cosine psi over the sine of psi. I keep saying psi because that's the name of this symbol. The symbol is called psi. It is spelled PSI. All right, so tangent of half of psi is this. So this equals 1 minus, we'll find the cosine of psi. Go to the triangle that has psi, this one. Give me a cosine from your position. Cosine would be adjacent over hypotenuse. Now sine of psi. Sine would be opposite over hypotenuse. So this is technically the answer there. On your calculator, if you just type it in, it should tell you, it should clean it up to whatever the answer key said. So that's number 1, part B. Now number 1C says the cosine of negative theta plus 56 pi. Recall from your notes the periodic properties. If you're going to add 56 pi, that's like adding a bunch of revolutions, but you end up wherever you started. So what I'm basically saying is that can basically go away. So this equals cosine negative theta. The 56 pi goes away because of periodic properties. Now, looking at your trig IDs, go to your even odd, and you'll see that cosine negative theta is the same as cosine positive theta. So just tell me cosine of theta and we're done, which is why the answer says 4/5. Yeah. Number 1, part D. The sine of psi plus 5 pi over 4. I would look at the sum identities in your cheat sheet. So look, sine, sum identities for sine. That formula would say that this equals, so this would equal sine alpha cosine beta, right? Sine of A times cosine B plus cosine of A times the sine of B. So we have 4 pockets, 4 individual pieces to deal with. Looking at the first one, sine of psi, go to triangle that has psi. Sine would be opposite over hypotenuse, multiplication. Cosine of 5 pi over 4, just go to your unit circle. You don't need these triangles to find cosine of 5 pi over 4. Just go to unit circle, tell me what that is. The cosine of 5 pi over 4 should be negative square root 2 over 2. Plus cosine of psi would be, go to psi, adjacent over hypotenuse, times. And similarly, the sine of 5 pi fourths, use your unit circle, you'd see that it's negative square root 2 over 2. And then go calculator on all of that to get your answer. Done, done, done. With number 1. Now for number 2. Well, for number 2, you have a wave and you have a beginning and an end. You have beginning and you have end. And you know that the top is at 12 and the bottom is at, does it say? It doesn't say the bottom. But you know that the middle is 5. Yeah, that's what it says in the picture, right? And we know what the goal is. The goal is to write an equation for part A that goes y equals a sine of b times x minus h, close, plus k. So we have a sine wave. We have the sine equation. Recall that k is the middle line, which in this case is 5. Now find a. So from the middle, how much did you have to go up to the top? Well, we're going from 5 to 12, so that's going to be 7. But is this 7 positive or negative? Based on what you see, it's positive because the graph goes up and then it goes down. If the graph was down and then up, it would have been negative. So positive 7. Now, find h. H is the x-coordinate of the start point, which is actually given to you on the paper, on the review. It says 3 pi over 4. The only thing you need now is b. So to find b, recall you have period. Period equals 2 pi over b. But recall, another way to define period is to look at the last x-coordinate minus the first x-coordinate. And we have that. We have the last x and we have the first x. So the period would be the last x-coordinate, 19 pi over 4, minus the first x-coordinate, which is 3 pi over 4. This gives 16 pi over 4, which is just 4 pi. That's the period. So 4 pi can replace the word period. So we have 4 pi equals 2 pi over b. Use your algebra to discover that b is 1/2. That is the value of b, 1/2. Because 2 pi divided by 1/2 becomes 4 pi. So we just found b, 1/2. So final answer, y equals 7 sine of 1/2 x minus 3 pi over 4 plus 5. That's the answer to part A. Now, part B, they want you to, I'll do this in a different color. Let's go green here. I'll do part B in green. The goal is to find f of 79 pi over 4. And for part A, instead of calling it y, they wanted you to call it f of x. So basically for part B, all they want you to do is take 79 pi over 4 and plug it in for x right there. And then on your calculator, type in all of this on the right-hand side, and boom, you'll get the answer like that. Basically, this was the x coordinate. You find the y coordinate by taking x, plugging it in for x, calculator, it tells you y, the y coordinate. Done. That's part B. Part B. All right, moving on to number 3. Let's look at number 3. They tell us what W is. So for number 3, they say W equals, let me zoom in, 1 plus tangent. W equals 1 plus tangent. And they want us to show that W squared equals 1 plus sine 2 theta. Cool. Over cosine squared. Let's do it. So W squared. Well, W is 1 plus tangent. And we're supposed to raise this to the power of 2. So 1 plus tangent times itself, right? When you raise something to the power of 2, you times it by itself. Now let's distributive property. Let's go 1 times 1. That's 1. 1 times tangent is tangent. 1 times tangent is tangent. Tangent times tangent is tangent squared. What else? Okay, how about this? How about 1 plus tangent squared? Let's rewrite this. Let's shuffle some pieces around. So watch what I just did, folks. I kept 1 in the front. I shuffled tangent squared over here. And then I said tangent plus tangent is 2 tangent. So everything's there. Now, how about 1 plus tangent squared? Looking at your trig identities, 1 plus tangent squared, it's right there. 1 plus tangent squared is the same as secant squared theta. Plus, well, this has to stay the same. 2 tangent. So how about this? How about I go 2 and tangent is sine over cosine. That's what tangent is. How about over here? How about secant squared? I write it like 1 over cosine squared. All right, you with me so far? Right? Secant squared is 1 over cosine squared. 2 is 2 times sine is 2 sine over cosine because 2 has a 1 beneath it. Now, how about you look here? 2 fractions being added together, but nah, the denominators are different. So let's make the denominators the same. How about I multiply top and bottom by cosine? Because then the denominators would be the same. Right? I'd have 1 over cosine squared plus 2 sine cosine over cosine squared. Because cosine times cosine is cosine squared. I have a common denominator, so whoosh, combine 2 fractions into 1. And so this would become 1 plus 2 sine cosine over cosine squared. But then remember that here in orange, 2 sine cosine is just sine of 2 theta. That's your double angle identity. 2 sine cosine is just sine 2 theta. And then if you just stop and look at what you were trying to make this match with, we're done. We have verified this identity. Okay, so for number 4, they tell us that the central angle is 25, and they say that this guy is 30, and they say that this one here is 26. So, and then for part A, they want you to find the area. So just use that one formula, 1/2 AB sine of theta. Remember that we did that areas of triangles where A and B are the two sides, and in theta is the angle that's sandwiched between the two sides. So you can just go for your answer right away. 1/2 30 times 26 times the sine of 25. 25 degrees. Type that into your calculator, and boom, you'll get the answer that's on the answer key. Done. End of story. Okay? Actually, let me type that in because I need to know what that is for part B. 26 times the sine of 25. So it's about 164.82. So 164.82 for part A. That's the area of the triangle. 164.82. Let me write that down somewhere. So for part B, I know that the area of the triangle was 164.82. And I need part A to do part B, I believe. For part B, it says that the shaded area, right? The area of the shaded is 133.405. And then they say, use your answer from A to find the length of the radius. What we want is the radius. How about we do this? How about I take red and I shade in this little slice of pizza. It's a little sector. That little red sector, think of it as like a slice of pizza. And you know what? We can find the area of the red. Look. Area of the red region is going to be the whole triangle minus the shaded part, which was this other guy. Just use a different color for that, I suppose. Just go green. And so we can find the area of the red by going the whole triangle minus the green stuff. And that says 31.416. That's the area of the red. But hold on. Let me draw the red thingy. It looks like this. And I need you to go back to the very first week of school where we found the areas of sectors. First week of school. And to find areas of sectors, back then, we said there's a formula for this. And there's a few formulas, a few different ways. So one way is to go, here's one technique, right, for the area of this guy. So the area of this could be, you could go m over 360 times pi r squared. Pi r squared is a full circle, but m over 360 takes the appropriate size bite from that circle. For this problem, since our slice of pizza had a central angle of 25 degrees, 25 degrees would go in for m. And what would go in for area? The area of the sector, 31.416. So we have 31.416 equals 25 out of 360, because that's how much you want to take from the circle, because the full circle is 360, but we only have 25 degrees of those 360. Hence, 25 sixtieths times pi r squared. So from here, take a calculator, and maybe you can divide both sides by 25 3/60ths. These would cancel. So my calculator, let me divide both sides by 25 3/60ths. Type that in carefully. And I get back 452.39 equals pi r squared. Divide both sides by pi. And I get about 144 equals r squared, square root. And you can then see how they got the answer of 12 for the radius of the circle. Let's keep going. Number 5, solve an equation. This one's not bad. So for number 5, we have 2 cosine of theta sevenths minus 120 plus square root 3 equals 0. So why don't you subtract the 3 and then divide both sides by 2? That'll tell us that cosine of theta sevenths minus 120, I think my stylus just went bad on me. Just kidding, there it is. Minus 120 equals negative square root 3 over 2. Now, how about we make a u substitution? How about we let u represent theta sevenths minus 120? So now we can rewrite this equation in terms of u. So this becomes cosine of angle u equals negative square root 3 over 2. So give me an angle u where cosine is this. Recall, cosine is the x-coordinate, unit circle. Give me an angle where the x-coordinate is negative square root 3 over 2. That would happen here or possibly there. So the values of u, let's go over here. The values of u could be 150 or possibly 210. Those are the u values, but the goal is to find theta. So take 150 and plug it in for u there. And then take 210 and plug it in for u there. 2 setups, 2 answers. Let's find them both. So one case would be 150 equals theta over 7 minus 120. Let's solve that case. Add the 120 to the other side. You get 270 equals theta over 7. Multiply both sides by 7. Theta equals 1890. And then do the other setup. You'd have 210 equals theta over 7 minus 120. But in the directions, in the directions, they wanted the smallest answer of theta. If I continue with this here, I'll get a theta bigger than 1870. And I want the smaller answer because the direction said that's my final answer right there. For number 5? Yeah, for number 5. So let's continue with number 6. All right, so for 6, we have p of x equals sine of x. And then we have q of x equals cosine x. Part A. Find the value of q composed with p inverse at 5/6. Well, recall that the composition could be rewritten like this. This problem could be rewritten as q of p inverse of 5/6. But I know p of x, I know q of x. This says p inverse. The heck is p inverse? Let me switch colors on you. Let's go green for a second. So if I take this and if I take this, if I take the inverse of p, it'll literally say p inverse. If I take the inverse of sine, it would literally say sine inverse. And that's what this wants me to do. This is telling me go to p inverse, which is this guy, and in for x, plug in 5/6. That's what this is telling me to do. So I'm going to do that. So I'm going to say p inverse of 5/6 equals sine inverse of 5/6, because whatever you plug in there, you have to plug in there. Now, let's go back to the main problem. Q is Q, but inside, what could replace P inverse of 5/6? P inverse of 5/6 could get replaced by sine inverse of 5/6. Now I want you to stop. I want you to pause, and I want you to remember that anytime you have inverse, you can create an angle theta to represent that expression. So I could go here in pink, and I could say let theta equal sine inverse of 5/6. And then recall what we did when we learned this. If I take the sine of both sides, this would say sine theta equals 5/6. This means I could make a picture with theta where sine is opposite over hypotenuse. And Pythagorean tells me square root 11 for the missing leg. Now go back to the main problem. Here is Q, but inside of the parentheses, what could replace sine inverse 5/6? Theta, because theta equals sine inverse 5/6. Now we're at the last step. The goal here to finish is take theta, plug it into Q. Q is up here. So they want you to take theta and plug it in there, and consequently plug it in there. So final answer, Q of theta would equal cosine of theta. Go to your triangle with theta and give me cosine from that position. Cosine would be adjacent over hypotenuse, which is why this is your final answer. For number, what was that? That was number 6, part A. So that's 6A. Let's go to 6B. Let me get all this off the page. All right, 6B. So that says Q inverse of negative P at 7/6. So let's rewrite this as Q inverse of negative P of 7/6. So I want you to focus only on the blue. Turn the blue into a number. The blue says to plug this fraction into P right there and right there. So let's do that, some scratch work. P of 7/6 equals sine 7/6. Hey, here's your unit circle. Use your calculators. The sine of 7/6 should be -1/2. Yeah. So back over here. Q inverse parentheses, a negative symbol is there. Now replacing this box is -1/2. So now you have a negative, which becomes positive. So this is Q inverse of 1/2. I know P, I know Q, but this is Q inverse. So quickly build Q inverse. If Q is cosine, then Q inverse would equal cosine inverse. And they want you to take 1/2 and plug it in there and plug it in there. So this would equal cosine inverse of 1/2. And you have a calculator. Type in cosine inverse of 1/2. Your final answer is whatever the calculator says. Should be like a 60 degrees. Should be 60 degrees or pi over 3. I'll accept either one. Same thing to me. All right, 7. You're asked to find the height of a wall. From a point on the ground, you look up 20 degrees, and then you crawl. So you're on the ground crawling, and you look up. So here's the scenario for number 7. 7 should look like this. Here is the ground. Here is the brick wall. And you're basically at the ground. And you look up at the building at the start, and it said that the angle of elevation was 20 degrees. You stay on the ground, but then you crawl to a new spot. You look up again, and this time it's 60 degrees. And then you had crawled 80 feet. And the goal is H, the height of the building. Solve for H. Here's what I would do. Follow this routine. How about we let this distance be X, but the goal is H. Let's draw two triangles. Let's draw first, look, I'm going to draw the pink triangle. And then after the pink, I'm going to draw, check it out. I'm going to draw the green. Notice that the green includes the pink and then some. So two triangles coming your way. So one of them, the smaller guy, would look like this, where this is 60, this is X, 90, and this is H, right? And then the bigger one, the bigger triangle would look like this, where this is 20, this is H, and watch, this is going to be 80 plus X, right? Whole bottom part, because you're going to go all of this. And that is 80 plus X. Your right triangle is right there. So how about we go like this? I got two triangles. I have the adjacent and the opposite. And the goal is H. Let's go tangent. Let's go tangent both triangles, both angles, 60 and the 20. So over here, tangent of 60, tangent is SOHCAHTOA, opposite over adjacent. And the other triangle would say tangent of 20 equals H over 80 plus X. How about I get H alone in both equations? How about I multiply this equation both sides by X and this equation both sides by 80 plus X? So this would give me these equations. I would have these equations here in green after I did these red steps. So in green, I'd have these equations. I would have, let's go over here. We would have X tangent 60 equals H. And then we would have 80 plus X tangent 20 equals H. I'd have H alone on both sides of both equations. Now, isn't H equal to H? Duh, it is. So because H is equal to H, then all of this could be set equal to all of that. So I would have X tan 60 equals 80 plus X tangent 20. Now, how about on a calculator? How about you turn tangent 60 and tangent 20 into decimals? Tangent 60 is about 1.732. Tangent 20 is about 0.3639. So tangent 60 and tangent 20 could be turned into these decimals. So these equations would become 1.732x equals 0.3639 times 80 plus x. And then from here, you want to distribute this decimal, right? You want to distribute that decimal. So that would be like, we would have this. We would have here in pink, running out of space, we would have 1.732x equals 29.11 plus 0.363x. And then subtract 0.363x from both sides. These cancel. And on the left, we get like I'll go in here, 1.369x equals 29.11. And then solve for x by dividing. So we'd have 29.11 divided by 1.369. So x is about 21.26. But what the heck was the goal? The goal was h. So why don't you take x and let's say plug it in there and that'll tell you what h is. So 21.26 right there, times that by tangent of 60, and your answer is about 36. So h is about 36.83 feet. Whew. That one took a while. But there it is. And these kind of problems, they pretty much always follow this routine. Yeah. Let's keep going. That was 7. That was 7A and B, right? You have the picture, and then we solved for the height of the brick wall. Number 8. So we have a line. It's -3, and this is 0, 4. This is old school. So how about we go y equals mx plus b? And you know, b is the y-intercept. This line hits the y-axis at 4. So you know that b is 4. And you know m is the slope, rise over run. Well, from this dot to this dot, how much do you rise and how much do you run? You have to rise 4 and run 3. So we have 4/3. So y equals 4/3 x plus 4. This is the equation of that line. The goal is to write this in polar. So recall for polar, x equals r cosine and y equals r sine. So let's replace x and y with these formulas. So we would have r sine theta equals 4/3 r cosine theta plus 4. There's let's see. How about, you want to get rid of that denominator? How about we multiply everybody by 3? Multiply this by 3, and multiply this by 3, and multiply every term by 3, just to get rid of that denominator. So this would become 3r sine equals 4r cosine plus 12. No denominator. Now, you want r alone. In the directions, they said, hey, get r alone. So to do that, move this piece to the other side. So we would have, let me get rid of some of this. Right? Subtract anything with an r, move it to the other side. Anything that has an r. So we would have 3r sine minus 4r cosine is 12. Then factor out r as a common factor. So r is outside alone, and then to get r alone, you divide r, or you divide both sides by the parentheses. So r would equal this here. And on Desmos, if you typed in our equation from rectangular and this equation in polar, one graph, not two, because they are the same thing, just in different languages. All right, last one. Cool, we end with the Moiv's term. And then after, I have a little tip that I want to show you, just a little piece of advice. All right, let me erase all of this here. Number 9. So we have, basically, we have -2 plus 2 square root 3 I, and that's going to be raised to the power of 4. So recall, maybe we can write this complex polar. Right now is complex rectangular. Let's write this in complex polar. How? Maybe first make a graph of this. This complex number, if you were to graph it, it's going to be somewhere in quadrant 2, where this is -2 and this is 2 square root 3. Find r with Pythagorean third. So in parentheses, this would be your setup in parentheses. This would be 12 plus 4, 16 square rooted. So r is going to be 4. R is going to be 4. Now for theta, how about you find little baby alpha? So let's find little baby alpha. We know that we can go tangent of alpha equals opposite over adjacent. So alpha would equal tangent inverse. And if you have to, take the absolute value of that, whatever your calculator says. And it should say that for alpha, you should get 60. It should be 60 degrees there, which means that theta has to be 120 because the whole thing or the half is 180. So if this portion is 60, then theta, the piece that takes you there, should be 120. So we just found that theta is 120 and that r is 4. So let me get all this off the board. We just found r and we found theta. So this here could be rewritten as r cosine theta plus I sine theta. So we went from complex rectangular into complex polar. Now de Moivre's theorem says take the 4 and it becomes the power of this, and then it becomes multiples of these. So we have 4 to the 4 cosine 120 times 4 plus I sine 120 times 4. 4 to the 4 is 256. And this becomes cosine 480. I sine 480. Calculator in degrees. Calculator in degrees. Distribute 256. And it's what the answer says. Negative 128 plus 128 square root 3i. So you go from complex rectangular into complex polar. Apply de Moivre's theorem correctly. Calculator to distribute the rest of the way to the final answer. So the last thing I want to just throw at you is this. What do you do if you see something like this on your homework, on a midterm, on a test, on something like this? What happens if you see something like, let's say, theta equals cosine inverse, let's say, of, how about square root 3 over 2? Let's go negative. What if I asked you to make a picture of this? Which quadrant are you in? Recall some facts. Recall sine inverse goes from negative pi over 2 to pi over 2. And that's the same for tangent inverse. So if you have sine inverse or tangent inverse, you're somewhere either in quadrant 1 or the negative quadrant 4. However, if you're in cosine inverse, you're somewhere between quadrants 1 and 2. So for a problem like this, if it says cosine inverse, we can make a picture. If you want, you could take the cosine of both sides, and this would say cosine theta equals negative square root 3 over 2. Now, because it started with cosine inverse, you know it's going to be either quadrant 1 or quadrant 2. Because cosine is negative, that means go to quadrant 2, and cosine is adjacent over hypotenuse. And you could use Pythagorean or whatever to find any missing legs. So another quick example, just to make sure you're with me. What if you see something like theta equals sine inverse of 2 over 7? Let's make this negative 2 over 7. Where do I go? What quadrant am I in? Maybe first take the sine of both sides. So you know that sine is negative 2/7. If sine is negative, you're either going to be in quadrant 3 or quadrant 4. But then recall your notes. Your notes said that if you have sine inverse, you're somewhere in quadrant 1 or the negative quadrant 4. That's from your notes. Sine inverse is either 1 or 4. So because sine was negative, it was options 3 or 4. But based on this discussion, you would be in quadrant 4. And it would look like this, where sine is opposite over hypotenuse. And in Pythagorean, to find any missing legs. If you have any questions, let me know. Have a great weekend. I'll see you guys next week for your final exam.